Hi folks, so in last episode we had studied vectors, scalars, revised the whole thing which we have done before. We have studied that how the vectors are being represented, what are the vector quantities, and we have touched upon what is the position vector. So, coming back to the same point in the same slide, I will prolong for the displacement vectors etc. to understand it better. Now, see this we have done. Suppose if at the origin, for convenience we always try to start the motion from origin 0 0, so that it becomes easier convenient to explain. So, lesser number of terms, lesser mathematics, lesser expressions, lesser conversion. So, at this point 0 0 we start. So, say an object, a body starts from point O, that is origin. Now, it moves in a particular direction and reaches to point P and travels by a vector quantity called r. R is a normal general notation for displacement, r or s. These are the normal conventions. Now, this OP, the vector OP, whose magnitude is nothing but the dimension of OP, how lengthy it is. So, this is our magnitude of this vector. Now, if you have person has moved through this blue line, you see the blue line gives you the exact path through which it has traversed. Now, at this particular point P, this is xy plane. Now, at this point P, at this particular point P, at this instant P, the position vector is OP r given by r. Now, so this is OP is the position vector at time t. Now, it has come at time t1, at some other time t dash or t1 whatsoever you call it, the position becomes p dash. Now, the position vector is r dash. How much it has moved from p to p dash? Look at this point, how the vector algebra is different from simple algebra. Look, you can't just simply minus r dash minus r. If you do that, you will be lost. You can try doing it, you will be simply lost. But here you have to do some vector algebra, some r dash minus r. I will do it. So, but this will be simply this, for this time between t and t dash, the initial point is this p and the final point is p dash. So, the line joining these two, the shortest line joining these 2 points is the displacement between p and p dash, means between time t to t dash. See, look, now in this graph what I have shown an another situation where an object starts from point P, goes to point Q. Unlike here, basically both the graphs are same. Unlike here, where the particle started the journey from the origin, here the particle is starting from the journey from point P. Now, if you see that this particle may start moving along this path, the blue paths you see. Here I had shown only one path. Here now I am showing different paths. One blue path is this, another path is this, or this could be this. In all these cases, no matter whatsoever the direction is, whatsoever the path is, if the initial and final points are same, so the r dash, the vector, the displacement vector will be the same, will remain the same. The displacement vector will remain the same in all situations where, if provided the initial and final points are the same. Now, let us do some vector algebra. Now, I am sure by this all these discussions which I have made so far, you are able to understand that the path length is always more than the displacement, or at the most equal to the displacement. This is your displacement L and whose magnitude is small l, and which is always less than path length. So, displacement vector is the straight line between the initial point and the final point, as we have seen in the case P to Q or O to P or P to P dash or O to P dash directly, whatsoever it is. Okay. Initial point and the final point, these are the 2 points which are important in vector algebra. In simple algebra, all the points, all paths are important. Now, let us do some vector algebra. Let us do some more vector algebra. I spoke that I will be telling about how to add 2 vectors, how to subtract 2 vectors, how to multiply two vectors. This multiplication of two vectors I will not be doing today. This will be done when we will be doing the chapter 7 on rigid dynamics. That will be, because that will be used there. Remember, this is a course in physics. So, I will be using the mathematics where as and when it is required. I will not be doing the mathematics in a consolidated way at one point. So, as and when it is required, we will doing it, but this is just for information that the two vectors can also be multiplied. Likewise, they can be added, they can be subtracted, and I will be telling you how to multiply a vector, how a vector quantity is multiplied by a real number. So, this is all about this chapter for the motion chapter. So, equality of vectors. So, the vector A and B are said to be equal if their magnitudes are same, and both are in same direction. Remember, both have to be the same direction. Suppose there is a vector O which starts from point O and goes to point P. Initial and final points may be different, does not matter, but the magnitudes are same. The two magnitudes are same, O to P and Q to S. These are two different vectors, because they may be taking place at different positions, because the initial positions are initial and final positions are different. So, the two, but yet since their magnitudes as well as the directions are same. So, both the vectors are equal. Now, look at this, A dash and B dash, contrary to it, initial positions are different, final positions are also different, their magnitudes are same. The magnitude of A dash, how do we write it? Modulus of A dash. This is how we write the modulus or the magnitude of a vector. You know it, we did it in the last episode. Though here the two vectors have the same magnitude, but since their directions are different. So, this A dash is not equal to B dash. Remember, this will follow throughout, not only here in class 11, 12th, but throughout your career in physics or mathematics. You will read a full chapter, full chapters on vector algebra in your mathematics course as well. This is a well defined area in mathematics. We will study a lot about it through matrices, tensors, etc., etc. Do not worry, you will be doing it lot. Now, multiplication of vectors by a real number. How do we? Now, suppose this is a vector A, double it, multiply it by 2, means direction is not changing, only magnitude is changing by 2. So, now having understood multiplication of a vector by a real number which is positive, in which it is adding. Now, let us see what happens when it is multiplied by a negative real number, negative number say minus minus 1. If you multiply it by minus 1, it means now it is minus, friends. What is the meaning of minus? It means the direction is becoming opposite. The meaning of minus is direction is opposite, right. So, if A is this, so minus A would be just 180 degree angle to it, having the same magnitude, just opposite to it, means making an angle of 180 degree. Let me repeat, the angle between A and minus A is always 180 degrees, just opposite, same magnitude, same linear direction, and the angle between them is 180 degrees. Okay, just reversing. Now, if it is multiplied, this vector A has to be multiplied by a number, real number, minus 1.5, okay, minus 3 by 2, right. Now, how to do it? This is the line, this is the vector, this is another vector which is representing same direction of this minus A, but half a time more than this minus A. So, this is your minus 1.5 A. Thus, you can conclude on this basis that suppose if you have a vector lambda A, what is this vector now? 2A. What is this vector? Minus A. What is this vector? Minus 1.5 A, right. Now, so all this, in this case lambda is equal to 2, in this case lambda is equal to minus 1, in this case lambda is equal to minus 1.5. Well, now the magnitude of this lambda A would be lambda modulus A, provided lambda is positive, is greater than 0. Okay, whatsoever if sign is there, so that will be brought down here. So, what is the magnitude of this vector? 1.5 times of A. This is the magnitude. What is the direction? Opposite to A. Okay. So, if you, what does that mean? That if you multiply a vector by a real number, the resultant quantity is again a vector quantity. Okay. If you multiply, I repeat, if you multiply a vector by a real number, whether positive or negative, the output or the result quantity is again a vector. Okay. Is that clear, friends? Let us go ahead. Now, let us see how the two vectors are added and how the two vectors are subtracted, means the algebra of addition and subtraction. Let us say through a physical example, let us say, now force is a vector quantity, I told you in the beginning. Now, if I say that this is a object, I am putting a force here in this direction, one force in this direction, another force in this direction. Okay. Now, if this force is greater than the force here which is pulling up in this direction, say in this case, so it will move in this direction. So, it will move in this direction. Now, the resultant vector is in this direction, right. Now, suppose if these two vectors are not collinear, they are in different directions, then what we will be doing? Then what is happening? Okay. So, then I am trying to reach to a situation where you can find out the net results of different forces or different quantities which are applied on a single object at the same time, first at the same time. This is an example when the two forces are applying on it at the same time. This could be like this, at the same time and one after the other. Okay. So, I will be doing in both the cases. So, now this is the addition process. Now, there could be the two kind of situations, friends, when the two vector quantities or let us say two forces are applied on an object one by one. Okay. One by one, one first and then another second. There could be another situation when the different forces are applied at the same time. The kind of activity which I was doing here, in this case two forces are applied together. Now, if I say one force in this direction, now over this is another vector, another force now. So, now there are two forces, one force which is pulling up in this direction, right, and another force which is pulling up in this direction. So, the two vectors or the two forces or the two vector quantities are applied one after the other. So, there are two situations. So, similarly, in the same situation you will find that there are two laws of addition called triangle law and parallel law. Triangle laws are applied when the forces are applied one by one. There may be n number of forces, but they are applied one after the other. And in the case of parallelogram laws of addition, vector addition, the forces are applied together at the same time. So, let us first see the law, triangle law of, however, both the laws are equivalent, you will find. Now, you see there is one, this is the original point A, one vector A is applied in this direction, right, OA. So, this is P. This could be displacement vector, this could be force vector, this could be some other vector quantities which you have not studied so far, but you will see later on. Okay. One vector quantity is applied and then another vector B is in this direction. So, another vector one after the other, remember these are the vector quantities one after the other which are applied one after the other, means that first tail and then head. Now, another vector is applied, B vector, which is represented by PQ here, right. So, the tail of PQ will coincide with the head of first vector, that is at this point, right. Now, the another vector. Now, look at that picture of the hole, at the hole what is happening, the initial point was O and the final point is Q. So, the resultant vector is a vector whose tail is at O and whose head is at Q. Look this. So, this R is equal to A plus B. Let me come back to the notation. If I were to write, so then this is bold faces here, but we may not be able to do it. So, we do it like this, A bar plus B bar, same thing. Now, have you understood it, this point? Now, similarly, now let us see B plus A. First I took a case in which the vector A was applied first and then vector B was applied. Now, let us see a case when vector B is applied first and then vector A is applied. So, now the vector B is applied first q s and then look, the tail of vector B is here, which is applied first. The vector, since the vector A is applied later, so the tail of vector A has to coincide with the head of vector B, that is at point S, right. So, now we draw this vector here. Now, this is the final point P, right. So, now this is our R is equal to B plus A. So, this tells you the series of in what manner these vectors are applied, these vector quantities are functioning. If A plus B, it means A is coming first and then B is applied. If B plus A, it means B was there first and then A is applied. So, now B plus A. So, this vector quantities will be B plus A. Look at this vector and at this vector, both are same. Do you find it? Both are same, right. It means A plus B is equal to B plus A. It means A plus B is equal to B plus A, right. Now, let us see with 3 vectors. Remember, here it was a triangular law. See, we are adding it in the form of a triangle. So, it is a triangular law. Okay. This is how the terminology is coming in. Now, let us see it with 3 vectors. Vector A is applied first, then vector B is applied on it and then vector C is applied. So, this vector, it is easy to understand from these graphs that this vector will be A plus B, A and then B. So, this vector is A plus B, clear. Now, so this vector, now this vector is A plus B plus C, okay. A plus B plus C is this vector, A plus B plus this is the original point O, okay. So, this vector will give you A plus B plus C, okay, because A plus B plus C. So, this vector will give you A plus B plus C. Well, now here, now let us see what is this B plus C first. Let us do B plus C. We are changing the order of the vectors. We are changing the order of the vectors. B is applied first and then C is applied and then A is applied. So, B plus C plus A. This is B. So, B plus C. So, this is my B plus C vector, right. This is my B plus C vector. This is my B plus C vector. Now, this A vector. So, this is the tail and this is this. So, this will make this will give you again A plus B plus C. So, you are seeing this relation. So, and this is called associative law of vector addition. This is called associative law, means it does not depend the order of the vector quantities in which they are applied. A plus B plus C is equal to C plus B plus A is equal to C plus B plus A, or whatsoever the order you apply them, they are all same. So, this is called associative law of vector addition, and this all mathematics which I have done here comes under the triangle law of vector addition. Now, I believe it must be clear to you that how these vector quantities are different from scalar quantities, and why we have not told these scalar and vector quantities before you were in class 11th. We did not discuss in class 9th, purposely because we were not aimed to tell you about this vector algebra at that point of time. So, having said this, because many a times if you ask your teachers, they might confuse you or they might say you that the vector quantities are the quantities which are having magnitudes as well as direction. It is incomplete definition, my dear friends. The complete definition is that the vector quantities are the quantities which have magnitude and direction, but at the same time follow the vector law of addition, which is a special law of vector addition. So, okay, these 3 points are required for defining a vector quantity, otherwise you have seen the electric current. Electric current, though it has direction, it has magnitude, but still not a vector quantity, it is a scalar quantity. Now, after having addition, let us see the subtraction of the two vectors. Let us say the vector A in this direction and vector b another vector b here. Obviously, we have to do a minus b, a minus b. So, I can write a plus minus b as a plus minus b. Is that correct? I will be doing the same thing here. I have written b, now I have just reversed its direction. So, it becomes minus b. This was b, so this is my minus b. Now, let us add this vector and this vector. Let us see how it happens. So, this is my vector a. Now, this is my minus b vector. What is minus b vector? Here it is minus b vector. Okay. So, the tail of this resultant and the head of this resultant will give me the resultant vector r 2, which is a minus b. Now, at the same time, let us see a plus b. Let us see what happens a plus b. Okay. A b. So, the resultant vector is this a plus b, which we have denoted by a plus r 1. Look, an interesting thing here. Look at the magnitude of r 1 and r 2. Look at the magnitude of a plus b and magnitude of a minus b. You might be wondering about it, that the magnitude of r 2 is more than the magnitude of vector r 1. So, magnitude of a minus b is more than the magnitude of a plus b. So, is it not interesting that the two vectors are being added differently? So, this is completely different from the simple algebra, friends. The whole everything depends on the directions on which the two vectors are being applied. Now, let us see the parallelogram of law. Now, addition of vectors using parallelogram. Now, if you see the two vectors OQ and OP named as B and A respectively, they are applied at the same point O at the same time, this case at the same time, right. Now, what will happen? Now, how to add it? Because these are, now you cannot put the tail of it here, you cannot appropriately put the tail of it here, because the two vectors are applied at the same time. Now, what to do? Now, what to do is this, you draw a parallel line to it from this and this is, now join these two, now join to these two. So, you have made a parallelogram here and the hypotenuse of this parallelogram will give you the resultant a plus b. Now, similarly, this here you see, now a plus 1, this was your triangular law. How the triangle law and these laws are equivalent, you see, I said, I made this statement before, that the triangle law of addition and parallelogram law of vector addition are equivalent, same. Now, had it been, now here you are seeing that the two vectors are applied at the same time simultaneously. If these are not simultaneous, these are one after the other, you will get the same result. So, this is equal to this, you are going to get the same result. And similarly, as we said last time, the associative law is also again applied here and you can do it on your own. This associative law of vector addition is equally applied again here, and this is how parallelogram law is equivalent to triangular law of vector addition. Draw. Now, resolution of vectors. Now, how do we see it physically? Let me first explain it, physical meaning of it, friends. Now, let us see, this is my, let us say this is my plus x axis and this is my plus y axis, right. This is one axis, this is another perpendicular axis to it. Okay. Now, if this is a object kept here at an angle with x axis or similarly at an angle with y axis, right. None of these angle is 0. So, it is slant. Now, if I put a force here like this, what will be the effect of this force along x axis and along y axis? This is what the meaning of resolution. This is the word resolution is no different from its dictionary meaning. The same meaning is here. Now, let us try to understand how we find these effects. How do we resolve? Now, suppose first forget about it, that in which direction, what are the directions, just general situation. Let us say this is a vector A. This is one direction B, another vector B and another vector small a. Okay. Now, if a vector is applied like this in this direction, what will be its effect in this direction or in this direction? This is something like, let me make a simple algebra. If I write, suppose if I write R, and let us say this is dependent on two quantities x and y, right. So, now I can always make a combination of these a x and b y. What are the values of a and b are, that will depend on situation to situation. I can always write any quantity in the form of its descendants or the quantities on which it is depends on, or wherever I want to see their resolutions, right. So, it may be, if r is along x axis, then obviously my b becomes 0. On the other hand, if r is along y axis, then obviously this a becomes 0. So, this is how I can always decompose them. The same practice I will do it here in the vector algebra as well, the similar activity. Now, I will draw a, suppose my a vector is here, right. Now, my b vector is in some other direction, say. So, I will draw a vector, my capital A vector here. Okay. I will draw, what I will do first, that along a vector line I will draw a line. This is just a line along vector A, vector small a, right. Now, at some, from this point I will draw this vector B, just drawn vector B, okay, in the same line. And now, what if this is the vector B, suppose it comes only to this point. Now, I will keep on drawing this line further till it meets the line which I had drawn for the direction of vector A. I will keep on drawing it. Now, once I have drawn it, so I will find that it intersects at this point, right. Now, my B vector was this, my A vector was suppose this much, only this much. So, now this is multiple of A and this is multiple of B. So, I can write it lambda A and mu B. So, what I have done here is that vector A is nothing but lambda A plus mu B. I think this point is clear. This equation is written here, right. Remember, bold faces means vector quantities, non bold faces means scalar quantities, remember. So, the rectangle, so this is our, now let us come to this rectangular coordinate system. So, friends, in this episode I have done the resolution along two arbitrary axes A and B. In the next episode I will be doing it for rectangular Cartesian coordinate system. During this almost all this course of class 11th and 12th, we will be doing rectangular Cartesian coordinate system. You already know that there are other coordinate system, polar coordinate, cylindrical coordinate, spherical coordinate system. Those are little complicated. We might be using some symmetrical calculations in class 12th in magnetism for different coordinate systems, but largely we will be using rectangular coordinate system. So, in my next episode I will discuss about the resolution of vectors in rectangular Cartesian coordinate system, x, y, z, only, x axis, y axis and z axis. Okay, friends, till then stay safe, bye.